Well, on October 2nd, the 3i Atlas came closest to Mars within 30 million kilometers. And the high-res camera on board the Mars Reconnaissance Orbiter took several images of it. These are the highest resolution images we have. 3 times better in spatial resolution, about 30 kilometers per pixel, compared to the previous best image, which was the Hubble Space Telescope image. And that was a day after the government shutdown took over NASA, and we haven't gotten the data.
A new Hubble Space Telescope image of 3i Atlas has revealed a never-before-seen phenomenon, something that challenges everything we know about interstellar objects. For months, this rogue visitor has defied expectations with its unusual trajectory, unpredictable brightness changes, and bizarre emissions. But the latest images, taken in December 2025, capture something truly astonishing. 3i Atlas has been observed emitting a wobbling double jet structure, a behavior that has never been seen before in any comet or interstellar object. A strong jet emanates in the sunward direction, while a weaker, almost opposite anti-tail forms, reaching out away from the sun. This is unusual in itself, but what sets this discovery apart is the wobbling motion of the jets. It's as if the object is rotating, causing its jets to flicker and shift direction, seemingly defying the gravitational forces at work on it. This wobbling behavior is a direct result of 3i Atlas's rotation, and it challenges everything we know about how objects in our solar system behave when they pass close to the sun. Comets typically eject jets of gas and dust when they encounter solar radiation, but they do not exhibit such erratic, wobbling movements. What makes this even more remarkable is that 3i Atlas continued to emit these jets both before and after its closest approach to the Sun at perihelion, maintaining its sunward orientation despite experiencing significant gravitational deflection. To understand the significance of this, one must first grasp the magnitude of 3i Atlas's journey. It is not just any ordinary comet. This object is interstellar, meaning it has traveled from outside our solar system to cross paths with our Sun. Its path, originally predicted to follow a relatively straightforward trajectory, began to show signs of something more extraordinary. As 3i Atlas neared the Sun, its behavior began to challenge the conventional understanding of cometary activity. Scientists had always expected the object to behave similarly to other comets in our solar system, ejecting gas and dust as it encountered the Sun's intense radiation. However, this wasn't the case. The jets of gas and dust emitted by 3i Atlas were far more peculiar than anyone had anticipated. The jets appeared to change direction, wobbling and shifting unpredictably, as though the object was actively controlling them. The discovery of this new, never-before-seen phenomenon is just the latest in a series of unusual events surrounding 3i Atlas. In fact, since its arrival, the object has displayed a number of characteristics that make it stand out in the study of interstellar objects. It has become the subject of intense scrutiny by astronomers, with each new observation adding to a growing list of anomalies. Loeb, a leading astrophysicist at Harvard University, has been one of the foremost scientists studying 3i Atlas.
So that's the trick, and in fact there was a mission called DART where NASA demonstrated that colliding a spacecraft with an object can deflect it significantly. So that's possible. I mean, there are various methods to deflect them, but this method of preventing a rock from hitting the Earth does not work for a technological object because it can maneuver, or it may have an intent, or it may have abilities that we cannot cope with. It's just like ants in the crack of a pavement looking at a biker that passes nearby. They cannot do much about it. And that may be the situation when we encounter alien technology.
He has documented a series of remarkable anomalies surrounding the object, which has continued to defy our understanding of both cometary and interstellar behavior. Loeb's observations of 3i Atlas have identified no fewer than 15 separate anomalies, each more intriguing than the last. These include the object's retrograde trajectory, an alignment that places it at a 16-degree deflection during its perihelion, and its strange composition, which shows signs of having more metallic elements such as nickel and iron than typical comets. Unlike ordinary comets that contain large amounts of water ice, 3I Atlas has shown only a small percentage of water, making its composition even more curious. These are not just anomalies, they are fundamental questions about the nature of this interstellar visitor. Avi Loeb's categorization of 3I Atlas's anomalies helps to paint a picture of a highly unusual object moving through our solar system. The retrograde motion of the object is one of its most striking features. Most comets follow the same direction as the planets, but 3I Atlas is on an opposite course, coming in from the opposite direction. This in itself is an unusual feature that has already sparked debate about the forces acting on the object. Loeb has also noted the timing of its arrival. The object's closest approach to both Mars and Jupiter occurred in a way that seems to defy the odds. The trajectory of 3I Atlas was calculated to have an extremely rare alignment with both planets, a coincidence that made its approach even more interesting. Perhaps the most perplexing aspect of 3I Atlas is its composition, which has defied every prediction and left scientists scrambling for answers. The object's jets, which provide the primary means of studying its composition, have shown a high nickel-to-iron ratio, a feature highly atypical for a comet. Comets in our solar system usually have a relatively low concentration of metals like nickel and iron, with their compositions primarily made up of volatile ices and dust particles. But 3I Atlas seems to be an entirely different class of object, suggesting that it may not have formed in the same way as comets we're familiar with. The jets themselves have also shown a startlingly low water content, with only about 4% water by mass, a far cry from the water-rich comets that make up the majority of interplanetary comets. This low water content raises significant questions about its origin. Is 3I Atlas an ancient frozen remnant from another part of the galaxy, or has it been exposed to conditions that differ drastically from those of typical comets? The negative polarization observed in the scattered light from 3I Atlas adds another layer of mystery. This is a phenomenon where the light that bounces off the surface of an object becomes polarized in a way that suggests its composition may be unusual. In typical comets, the light scattering behavior is quite different. The negative polarization observed in 3I Atlas hints that the surface materials or structure of the object may be fundamentally unlike the usual icy, dusty compositions found in solar system comets. This strange light behavior implies that 3I Atlas could be composed of materials that are not commonly seen in our solar system, perhaps even substances that are not found on Earth. Such anomalous features suggest that 3I Atlas may not be a typical icy wanderer from the distant reaches of space, but rather an object with an extraordinarily different origin, possibly shaped by unknown or extreme processes. In addition to these physical anomalies, Avi Loeb, a prominent astronomer studying 3I Atlas, has pointed out another fascinating aspect of the object, its gravitational deflection during perihelion. When the object passed near the Sun, it was deflected by an unexpected 16 degrees, a value far larger than would be anticipated for an object of its size and velocity. This deflection suggests that 3I Atlas may be interacting with gravitational fields in ways that current models do not fully account for. The observed deflection also contributes to the wobbling jet structure that has become one of the object's most perplexing features. As 3I Atlas rotates, its jets shift and wobble, seemingly influenced by both gravitational forces and the object's internal dynamics. The fact that 3I Atlas continues to emit jets with such precision, despite these complex forces acting on it, raises important questions about its internal structure and the forces keeping it stable. Equally puzzling is 3I Atlas's alignment with the solar ecliptic plane. This orientation was unexpected, as it goes against the trajectory models that scientists had predicted for interstellar objects. The object's interaction with Jupiter also raises eyebrows. Instead of being dramatically disrupted by the immense gravitational forces of the gas giant, 3I Atlas has maintained a remarkably stable path, continuing its journey with minimal deviation. This stability is especially surprising given the gravitational interactions that typically lead to significant alterations in the trajectories of objects passing near massive bodies. The lack of a more dramatic disruption in its path is another anomaly that challenges established models of interstellar objects, suggesting that 3I Atlas might be subject to forces or dynamics we don't yet understand. Beyond its strange physical behavior and composition, 3I Atlas has also exhibited unusual material properties that have further mystified researchers. Its brightness has increased at a rate that was completely unanticipated, leading astronomers to reconsider their models of how such objects should behave. It has also been noted that 3I Atlas appears bluer than most comets. This unusual color suggests that the object might be composed of materials that reflect light differently from the typical icy surfaces of comets. Solar-wind interactions with the object have also been unusually weak, with no signs of the expected decay typically seen in objects of its size and composition. Instead of rapidly disintegrating or releasing large amounts of gas, as expected from comets near the Sun, 3I Atlas has displayed an unexpected resilience, suggesting that its material properties may differ drastically from what we would expect. As 3I Atlas moves closer to Jupiter, it will provide invaluable data that could shed light on the forces at work in shaping objects that originate from outside our solar system. The gravitational interactions with Jupiter will be crucial in understanding how these objects behave in the solar system's environment and whether they can survive such intense forces without breaking apart or drastically altering their paths. The object's strange behavior and unusual composition continue to intrigue scientists, and as it moves further into the solar system, it will likely offer even more insights into the nature of interstellar objects. 3I Atlas may be the key to unlocking new knowledge about the formation, composition, and behavior of objects from beyond our solar system, and its journey will no doubt continue to be one of the most closely watched events in modern astronomy. Despite the many mysteries that remain surrounding 3I Atlas, there is still much to be learned. The object's journey toward Jupiter will provide new opportunities for study, and as it moves through the solar system, scientists are eager to see what new anomalies will emerge. The latest discovery, its wobbling double jet structure, is just the beginning of what may turn out to be an even more significant story. What we know for sure is that 3I Atlas is no ordinary interstellar object. It is a cosmic enigma that continues to defy the expectations of scientists and astronomers around the world.